a mixture of two couples, or in other words, given an overall reaction, redox reaction. We actually already solved a few of these, but we're going to see. For an overall reaction to go in the forward direction, okay, that means that the oxidizing agent, EOX2, should have a higher potential than the oxidizing agent, OX1. That means that this is the better oxidizing agent, and thus the reaction goes in the forward direction. If the two E's, E1 and E2 for the two couples, okay, is the same, then the reaction does not evolve, and actually there is no reaction, it stops. And it's already reached equilibrium. If the E1, and دغري أنا بقول E1 بتطلع بالoxidant, guys. I don't look at the reductant because I look at it from the reduction side. And these are reduction potentials. So I look always at the oxidant. اللي هي ox plus number of electrons becoming the reducing agent or the reductant. So I always look at it from the reduction perspective. So I look at the ox, the higher E for ox plus electron going to red is, so if this is E1 and then E2, the higher the E, the greater tendency for this to be the stronger oxidizing agent. So OX2 is, if E2 is greater than E1, then OX2 is the stronger oxidizing agent. Thus the reaction goes forward. However, if E1 is greater than E2, then OX2 is the stronger oxidizing agent, and the reaction goes in the opposite side. Now, there's something here that really I find, I don't know why they bother to derive K in this fashion, but I'm going to just show it to you briefly. K is the activity or concentration of products divided by that of the reactants to the stoichiometry. Yes, yes. When we've already reached equilibrium, كلمة equilibrium means that the cell has stopped. That means that the potential of the cell has eventually become zero. And that tells me that E2 minus E1, or E, actually, overall, E of the oxidation half reaction minus E, the reduction half reaction minus E of all the oxidation half reaction become zero. Thus, E of the reduction half equals the E of oxidation half, and we call this E of the solution. That's when we reached equilibrium. This idea becomes very important when we're doing titration, next week, early next week. When we've reached equilibrium, we say that the E of the solution, the oxidation half, equals the E on the reduction half reaction. Again, even though these E's are reduction potentials, both. Okay. So if I have the reduction potential of the first OX1 plus N1E red one. If I'm writing the reduction potential, it's what? E naught 1 plus 0.0592 divided by the number of electrons transferred in this half reaction, log concentration of لأنه plus ox على red. In the second one, the E2 node plus 0.0592 N prime for the number of electron transferred for the second half reaction in the reduction form. Again, these are reduction potentials. And log, again, ox على red because it's positive. So for these two, the two reduction potentials are equal to each other. Thus, we've reached equilibrium. If I take the change in E nodes, yani what's the difference in the E node values? E naught 2 minus E naught 1, or if this is reduction minus oxidation. So we're taking E naught 2 minus E naught of 1. So باخد ال E naught 1 على هاي الجهة بتزبط وباخد هيدا البارت to this side. Okay? Thus, and if you do that, let me erase now. So I got this E1 جبتها لهون مشي حالها خلصنا من هاي, and this part I took there. صارت minus sign يعني when it goes there صار minus this end. Notice that's what we have, and I factored out the 0.0592 N here as a common denominator, N1, N and N1. It's factored out. That means it's already multiplied through. Maybe هيدي كأنه I multiplied it. I got a common denominator. أو خدوا هيدي ال N. If I multiply it by N1, N1 صارت N1 N وهيدي ال N1 or N prime sorry. N prime بفوتها على قلب هيدا لجوا صار هون ال activity of ox to the N1, activity of red to the N1. I hate the French way. Minus log كمان نفس الشيء هيدي ال N بعمل common N هون بضربها ب N ضرب N صار common وهيدي ال N بفوتها لهون فاتت. Okay. Net result N prime times delta E naught equals 0.0592 log activity of the reductant طلعنا log وهون subtraction يعني كان division. So صارت هيدي الريد لفوق. Red 2, ox 2, ox 2, red 1, and 0.05 log 2. We see that this part here is the K. Okay? And thus, log K equals N1 N prime delta E naught 0.0592. We just derived what I derived centuries ago in another way completely, this equation. So this is how the French derive that log K equals total number of electrons transferred N1 times N prime 1 delta E naught divided by 0.592. We derived it from the theories of thermodynamics and what we know about delta G, and we also got the same equation. Okay, that being said, you already know how to use this to get the K. هيدي N1 times N prime هي total number of electron transfer. Why did I discuss it, even though, you know, I don't like deriving K this way? Is because a little bit later, when we look at titration, I need you to know that when we reached equilibrium, reduction potential equals the two reduction potentials on the oxidation half and on the reduction half are the same. The two reduction potentials, and they are, we call this the E of the solution. And this comes about because the cell stops and thus the cell E becomes 0. Okay, so we already have this. Again, the N, instead of having N1 times N2, we just simply write it N for the total number of electron transferred, then I don't have to worry. Okay, there is this interesting part which, you know, can be useful, and that is when N is equal to 1, I put for N equals 1 here. And I put for K, okay, try the different E of the cell values. We try different cell E values. It turns out that when the delta E or E node of the cell, أمرار حتى أنا بحب حط delta E because then it shows that it's the change in E nodes. When this E node of the cell or delta E is 0.25 as a number, we see that the K is up. That's when we get a K that's approximately 1.5 times 10 to the 4, actually, exactly. And that's when the reaction is what we call it, that it is complete. So any values of E greater than 0.25, we will say E naught of the cell. If it's greater than 0.25, we will automatically say that the cell will go in a complete way. And if the change in E naught of the cell is less than 0.25 on the negative side, minus 0.25, if it's less than this, then the reaction is limited. This becomes useful on a diagram of E values. If you have E or E nodes, depending on, you know, if the reaction is standard or not. And remember with K, we're looking at E node values only. So if the E node في فرق بيناتهم, the difference in E node is 25 or greater, that means خلص, the reaction is complete. And this is something that we want to concentrate on, at least the complete part. All right, so that's exactly what we say. If the change in delta E is greater than 0.5, then the K reaction typically is greater than 10 to the 4, and the reaction is treated as complete. It's called quantitative. If the change in E naught of the cell is less than 0.25, then the K reaction is less than 10 to the minus 4, and it is limited, and typically limited, yani X is negligible relative to initial concentration. If it's in between, then the reaction takes place, but it's not complete or quantitative, and we likely might have a quadratic equation. Domains of predominance. Right. If we have a reaction where we're in standard state, Fe goes to Fe2 plus, a reduction half, then the E, we know, will depend on the concentration of the Fe in solution, the two forms in the solution. We already solved the question to this form. At the beginning of the reaction, we started with 1 molar Fe, 2 plus. Okay, and we started with 1 molar Fe3 plus. So both of them are at 1 molar. As the reaction proceeds, okay, the total concentration of both is 1 molar. Okay, the total concentration. يعني بالأول I start with 1 molar and the reaction, let's say like this, and the reaction is proceeding. Or maybe this was 0.6 and this is 0.4. I don't know. Whatever it is, that the total is 0. So بهيدي عم بيقولوا لي لا ال Fe2 plus starting is 0 and the Fe3 plus starting is 1 molar. As the reaction proceeds, the Fe3 plus concentration starts to decrease while the Fe2 plus concentration starts to increase until both are equal. And notice when these two are equal, what happens is the E becomes equal to E naught because the log value becomes log of 1 and log of 1 is 0. So E equals la E naught when the Fe3 plus equals la Fe2 plus concentration. So when they're equal, we have whatever the E naught is as a potential. Let's see, as my Fe3 plus concentration decreases, if this number is decreasing, the upper denominator, that means the log value is becoming lower. That means the E is going to be less. Okay, so thus we start with a high E, reduction potential, and eventually, as my Fe increases, E and E become greater. What am I talking about? I am lost. Okay, never mind. The point here is that when these two concentrations are the same, we get the E naught values. And so in this area before the E naught, and I drew a diagram before for you, E naught and then E. As the potential is increasing, we're getting more and more concentration of Fe2 plus. As the E is increasing, we have the reduced form. Always build diagram, we have the reduced, then oxidized. Reduced is Fe2 plus, oxidized is Fe3 plus form. So the diagram is in the opposite direction. I'll get back to you on this. I do want to take the take-home message of this, always. when the oxidized form equals a reduced form, that's when E equals the E naught. And if I put here, let's say 10% of the overall 10, and this is 90%, and 10 to 9 Fe. If you put these numbers in, if something predominates in a solution, Fe3 plus predominates, that means that كلمة predominance شو معناتها؟ معناتها ال Fe3 plus in solution is 10 times greater than the Fe2 plus. That means the ratio Fe3 plus على Fe2 plus إذا هيدي 10 times يعني هيدي 10 to 1. إذا بحط هون 10 to 1, okay, at this point, if I put 10 to 1, then you will see that there will be a plus sign here, plus 0.592. If the Fe2 plus predominates, بعد الراتيو هون عندي Fe3 plus على Fe2 plus. إذا ال Fe2 plus predominates, that means its concentration must be 10 times greater than that of Fe1. So هيدي 10 and هيديكي 1. كيف ال indicators? The same thing. Put 1 على 10 here, you get a negative sign. Right there. And so this, when Fe3 plus predominates, it's 10 times greater. That means we are here, we're هون in the ox means only Fe3 plus predominates, يعني it's 10 times greater than Fe3 plus 2 plus. Yani you've already reached 90% of it in solution, or you have 90% of it or greater in solution. And so you have here the E naughts plus or minus 0.0592 al minus sign or plus 0.0592. In this area, neither predominates. You have both ox and red, neither one is predominant. Only when 10 times greater does one of them become predominant. إذا بتتذكروا بالPKA للindicators قلنا pH equals pKa. بس بالindicator color كنا ناخد pKa minus 1 pKa plus 1 ونقول هيدا هون عندي الindicator H indicator color predominates. هون عندي الindicator minus color predominates. So in between, neither color predominates. It's exactly the same and it's solved in pretty much the same way. In this area, we have the reducing agent predominates. In this area, the oxidizing agent predominates, and in between, neither is considered predominant. بس هون مش plus or minus 1 لأن عندي رقم before the log value, while in the Henderson معنا we don't have a number. And so that's it for the predominance here.